Let's look at lesson 42, finding distance from a point to a line. The first thing we need to discuss is what is the shortest distance from a point to a line? Well, every time, the shortest distance from a point to a line is always going to be a perpendicular line. So I need to draw a line that creates a right angle with this line for it to be the shortest distance. And if I measured it, you can see that if I drew a line here or there, this line would always be the shortest. And that's what we're looking for here. So it has to be a perpendicular line from a point. Let's look at example 2. In example 2a, it says, find the distance from point P, and P is at 6, 4, to the line y equals 1. Well, these first two examples are going to be easier. Because all you have to do for the distance, since the line is a horizontal line and it's not diagonal at all, these are going to be easy. Because all you have to do here to find the distance is do absolute values. Absolute values. And so our y, you may be wondering, what is your y here? Well, our y equals 1. I don't know what the parentheses. And then our y here is 4. Doesn't matter which one is first. You can do 4 minus 1 absolute value and get 3, which will be your answer. Or, that looks like 11, bigger. Or you could do absolute value of 1 minus 4. That would give you -3, but absolute value, it would be 3. So your distance would be 3 units. Now let's look at example B, 2b. It says distance from P, 6, 4, to the line x equals 1. Well, if we're finding the distance from this point to x equals 1, and then once again, no diagonal, therefore we can just do absolute value of x1 minus x2, or vice versa. Our x here is 6. Our value for x here is 1. So therefore, 5 would be our distance. And that's how you do it when it has horizontal, when it's just a straight horizontal line or straight vertical line finding the distance, because you are going perpendicular. But those are very easy. You just do the absolute value. Now let's look at one with a slanted line. Example 3 says find the point on the line that is closest to point S, and then it wants us to actually find the distance from S to the line. So we have point S, and this line is y equals 2x plus 1. It gave us that in the example, I just didn't write it down. But what we're going to do here, remember we need a perpendicular line. Well, in order to find a perpendicular line, what we have to do is take the opposite reciprocal. So we look at y equals 2x plus 1, and we got to find the opposite reciprocal of the slope. Here is our slope. That is our m. So what we need to do is flip that to be 1 over 2, and since it's positive, we make it negative. So there's our perpendicular slope. Now, what we can do, this one's actually easier. What we can do is actually basically count. If we go up 1 to the left 2, we notice that it intersects right on the line, and it intersects at a nice smooth spot. 1, 3. You could probably see that better in the book. You can see where it intersects, but we know that that coordinate right there is 1, 3. So now that we know this coordinate, and we know this coordinate, well, in order to find the distance between two coordinates, what we do is the distance formula. Distance equals square root of x1 minus x2 squared plus y2 minus y1 squared. And then we plug in and solve. x1 is 3. x2 is 1. We should know how to do distance formula by now. y2 is 2. And y1 is 3. Then we continue to solve. 3 minus 1 is 2. 2 squared is 4. 2 minus 3 is negative 1. Negative 1 squared is positive 1. So you get 5, but it's square rooted. So square root of 5 is your distance. I don't know if it asks for decimal or anything like that. Oh, if you want a decimal, it'd be roughly 2.24, but either of those really would work. So that is your distance, and that is how you find the distance from a point not on a line to a line. You got to use the perpendicular slope.